So in this video we are going to discuss the next part of module 1, that is basic operational concept. So let's start. Basic operational concept means that is also known as the instruction execution cycle. Okay, so basic operational concept, or if the question is asking to explain the steps in the instruction execution cycle, both have the same answer. Okay, so first let's see what are the different steps here. Mainly you have to understand there are 4 steps. Okay, that is fetch is the first step. Fetch means control unit would get information from the memory. That is a fetch cycle. Now decode means what? Instruction is getting interpreted, instruction is being understood. Okay, now then we have execute cycle. Execute means ALU would perform the required in operation, or what it wants to do, it would calculate that. Store means the result is stored back into the memory or the register. This cycle would repeat again and again for every instruction. This is the main steps. That is, first we have the fetch cycle. In the fetch cycle, what happened? We will explain this with the example. Okay, in the fetch cycle, what happens is that the control unit will get the information from where the control unit gets the information from the memory. It would take the instruction from the memory. Like, let us say my instruction is add A plus B. So control unit, first what it will do, that it will fetch this instruction. Next thing is going to it understand is the decoding. That is, it would interpret this instruction, it would understand the instruction. That is, it will understand that okay, add is the operation. Okay, A and B are the data locations from where we have to access. Okay, so decoding is done, then it will execute. Now ALU would perform this addition by adding A plus B would be calculated, and finally the result, that is A plus B calculated, either it will be store it into the register, or either it will be given that value to the memory. Fine. So fetch, decode, execute and store the result back. These are the instruction execution cycle step, and you have to understand that this cycle would repeat again and again for each of the instruction. Understood? So this here, if you see in the slide, you have this example. That is, you are going to first you can see that loading location A comma R1. That means it would transfer the contents of the memory location A to the register R1, and then it will add that register R1 with the value in the R0 and place their sum in the R0. That is what it is doing. Okay, so here if you see this example, these are some examples of some instructions here. Add location A in R0 means it what? The instruction is fetched from the memory, and the operand at location A is fetched. That operand in here is fetched, and it is then added to the content which is present in the R0, and the resulting sum we will put it in this R0. Okay, the resulting sum is stored in the R0. Here we will, whatever the contents in this location A, we would fetch that and we load that to the register R1. Is this instruction means load means. Okay, now add R1 comma R2 means what? Add R1 comma R2 means we will add R1 comma R0, and the result is stored, the sum is stored into the R0. So this is how you have to understand the instruction. Okay, this is one important thing that you have to understand, what of these each instructions means. Okay, here you are fetching the operand at this location A, and you're going to add that with the operand in R, content in the R0, and the sum is stored in this R0 itself. Fine. So you have to understand, whenever an instruction comes, you should be able to interpret that instruction. Okay, now here if you see the connection between the processor, connection between the processor and the memory. Here if you see, this is our processor, this is our memory and input device. In and out things are there. Okay, now you have to understand, you have to understand here is that you have to see that in processor you have the program counter, instruction register, general purpose register, control and ALU. This we already know. But there are another thing that you have to understand is the MAR and MDR. Through MAR, the address can be given. It's only one way, to the memory only, because we know the data's address present in the memory or the instructions address present in the memory, that you have to give from which address you want to read or write, that you're going to give through here. MDR means data part, okay? It's a data register. This is address register part. So if it is data register part, means in and out, data can go from the memory or to the memory, two side it can happen, understood? So you have to understand this basic connection. Whenever the basic operational concept we have to discuss, this is important diagram, because these all are participating in the instruction execution cycle. These all components are participating, whether it be the PC, whether it be the instruction register, the general purpose register, the control unit, the ALU, all of them are participating. Memory, the input devices, and you have to draw this diagram like this, then only we will be able to understand how is the flow, right? Through this diagram only you can understand the flow, understood? So now we have understood that this is the main connection between everything. This is the main connection between everything. Fine. So we have the MAR, the MDR, the control unit, the ALU, the program counter, the instruction register, the general purpose, and general purpose registers are there. Those we have to write. The memory part is the input output part is there. Understood? So it is important from our side to learn this diagram. Okay. Now here if you see, I will explain this top level view, but first of all let's understand the different things. CPU registers, you can see here, first you have the instruction register. What does the instruction register do? What does the instruction register do? You are understanding each of the component, okay? What does the instruction register do? This is just the same diagram's top level view. You can just draw any diagram, it's fine, okay? The same diagram's top level view is what it is given here, nothing fancy, okay? So here if you see, we have the instruction register. What does instruction register do? Instruction register, it holds the current instruction which is being executed, and they send the control to the control unit for decoding. That means if I am currently executing, let us say add R1 comma R2 is what I am currently executing, let us say that. So that instruction is present, the currently executed instruction is present in our instruction register. And what do instruction register do? It would send that control of that instruction, it would send that control to the control unit for decoding purpose, okay? So that would be sent to whom? To the control unit. Fine. Now program counter would be storing the address of the next instruction. We know program means what? Program is sequence of instruction. So if instruction register has the address of the currently holding instruction which is being executed, then program counter would has to point to the next instruction, then only that instruction can after this instruction, currently whatever the instruction is there, after this instruction has been executed, then what happened is that the program counter has to do what? The program counter has to fetch the next instruction, which is automatically increment should happen. What it has to do next? So it stores the address of the next instruction. Then you have memory address register, that is MAR, a memory data register, not B, okay, data, it's D, data register. So memory address register, which holds the address of the memory location that you have to access. So if from the main memory some instructions, data and all are there, so I have to access from one memory location. I doesn't know from which location that instruction is present. So in order to memory to know from which instruction I have to access it, from which address position, you have giving the address to the MAR. So it would hold the address of the memory location that you have to access. Let's say address 1000 means I have to access from the address 1000, the data which is present in the address 1000 I have to read. Fine. Memory data register means it holds the actual data from the memory. That is, if I'm saying that if it is read, what happen is that memory would give some data to the CPU through the MDR. If I want to write the CPU through the MDR, it would give the data to the memory. Understood? So MDR is the part in which data is dealt, and MAR is the part in which address is dealt. Fine. So this is the main thing that you have to understand. Okay. So you have to remember this diagram. This diagram is very important, where we have the MAR, the general purpose registers, the instruction register, the program counter, the control unit, the ALU part, the MAR, MDR, the input output unit, the system bus, how the system bus in which the control unit MDR and MAR is basically connected. Only the address has one direction moment. All these things you have to understand. These are very important. Okay. Now we have this different parts. Why we are using this different parts that we have already discussed, which holds the current instruction and give the signal to the control unit for decoding is what instruction register do. Program counter, it contains the memory address of the next instruction to be executed. Memory address register, memory data register, hold the address to be accessed, and the data. Here is the data. Now we have to understand the fetch cycle and execution cycle is the last two things that you have to understand here. So first let us understand the fetch cycle step by step. First, the program is where? The program is in the memory. In the memory, how the program comes? Through the input device. Right, through the input devices, the program reaches the memory. Now program counter has the address of the next instruction. That is, it would contain the address of the first instruction or the next instruction to be executed. Now the contents of this program counter would be given to the MAR. So MAR would send us, because first it is present in the memory. Program counter contains what? The address of the instruction that you have to execute. So that address you have to give to MAR, right? So first, in our memory you have our program. Okay. So what happens is the program counter contains the memory address of that instruction, which it will give to the MAR. So MAR would give it to the system bus, that address. So what happened is that since MAR is sent that to the system bus, what happens is that the read signal would be given. So control unit will say, okay, read. Control unit will send what? The read signal to send data. So that instruction would be given to what? To the MDR. So from the address which is present, which is given by the AR, the instruction would come. So the control unit would send read signal. So the instruction is a read, and that is given to the MDR. Okay. The memory send the instruction to the MDR. Now MDR would give it to the IR, because IR holds the currently executing instruction. The IR would be, what happened is that then what happens when it reaches the IR, the instructions move to the IR. So then when it reaches the IR only, we can say that it is ready to decode and get executed. This is the fetch cycle. Okay, the instruction has reached here in the IR, then the fetch cycle is over. Fetch cycle is this, the instruction execution cycle. We have two cycles, fetch cycle and execution cycle. In the fetch cycle, we know the program is there in the memory. So program counter contains the first instruction and the address of the next instruction. That address would be given to the MAR. MAR would give that address in the system bus, and what happened is that in that address there would be an instruction. That instruction would be control unit would give read signal, and that instruction is given to whom? The MDR. MDR would then give that instruction to the instruction register. So when it reaches the instruction register, means the instruction is now ready to get decoded, executed. This is what my fetch cycle. Understood? Now we have the execution cycle. In the execution cycle, we have to understand that now our instruction is in the execution in the instruction register, but we need operands. So what we are going to do is that we are going to get operands from operands. For ALU has to do the operation, right? So the operands can be present in the general purpose register or memory. Okay, if operands is present in the general purpose register, then we can take it directly. But if it is present in the memory, what we have to do is that we have to give the address to the MAR first. MAR would read that from that address. It will read the data from the memory, and that data is given to the MDR. Then it is given to ALU. Fine. So if first there are two cases the operands are present. Either the operands can be present in our registers, or it is present in our memory. If it is present in the general purpose register, we can take it directly. If it is present in the main memory, the address from the main memory you have to access data that is given by the MAR, and it will read that data, and the data is given to the MDR. Okay, MDR now contains the data from the main memory, would give the data to the MDR. Now MDR can give it to the ALU. So now ALU can perform the necessary operations. Okay, now either the result can be stored to the registers itself, or it can be given to the memory. So if I want to store the result also, I have to give the address in which I have to store. So MAR would give the address in which I have to store. Okay, and the result is given by the MDR. MDR would give the result, and address to store is given by MAR. And then write signal will give, and we will write it into the memory. Understood? So during this time, program counter what happened, it will get incremented, and now it will point to the next instruction. So in addition to transferring data between memory and processor, computer accepts data from input devices and send data to the output devices. So in addition to transferring data between memory and the processor also, maybe input devices want to see some data. So maybe you can take the data from the input devices and you can give it to the output devices also. That can also come. In addition to this, between the memory and the processor, between input and output device also this can come. That is also basically possible. That is what we are saying, just possible thing. IO operations, if needed, IO operations can also be done, and the IO operations can be done using the IO address registers and IO data registers. You have IO address registers and IO. This is like I said here D, but buffer can also be called as memory buffer register, and IO buffer register means it's talking about the data itself, data register itself. So it's, if it was B, I just tell there, okay, it can be D, it's wrong. Memory data register can also be known as memory buffer register. And so if there is IO operations, if IO operations are needed, then through IO buffer register and IO address register it can be happened. Okay, if needed. Okay, that can also happen parallelly there. Fine, it is when if you are needed that. Fine, this is the part where this is the execution unit, this is the ALU part, that is what execution unit. Fine, this is just the top view. Then just we have to understand this, the main diagram between memory and the processor when we are discussing. This is the main part. Now if IO operations come, then buffer and this part also you have to discuss. Fine, so whenever you are taking basic operational concepts, the first thing is the fetch cycle. So the program is present in the memory. Now that address current, that is the instruction would be there in the program counter, that it will give to the MAR, and that it will give to the system bus, and control signal will give read signal. So that is read, that instruction which is present in there is read, and it is given to the MDR. MDR give to the instruction register. When it is reaches the instruction register, we say that okay, instruction is now ready to be decoded and executed. Now it reaches the execution cycle. Execution cycle means first we need the operands. Operands can be present in the general purpose register or in the memory. If it's present in the memory, you have to give the address from which you have to read that data. So MAR would give the address. Then read signals will give by the control signals. Control unit will give read signal, and that from the memory, that address positions data is read and it is given to the MDR. MDR would give to the ALU. Now ALU performs the operation. Now the result you can store it to the general purpose register, or you can store it to the memory. If I wanted to store it in the memory, I have to give to the address in which I have to store it in the memory, and the data also I have to give. So address is given through MAR, data is given to MDR. Then I will control signal will it will tell write to memory, write signal, control signal will give. Then finally program counter will get incremented for pointing to the next instruction. Now sometimes instead of memory and processor, sometimes between that input devices and output devices can come. So we will accept the data from input device, give to the output device. This I know is using the IO buffer register, that is IO data register, and IO address register is also present there. Okay, so these are basic concepts, and you have to remember this diagram which is containing the memory, the input output device, the system bus, the MAR, MDR, control unit, the program counter, instruction register, general purpose register, ALU. Okay, the top view also you can remember. You have the IO unit, IO module here. You have the system main memory here, Then you have the PC, the instruction register, the execution unit you have inside the CPU, MAR, MDR, IO buffer register, and IO address register. All this we have. So top view also you can remember. So these are the things you have to remember in here, the basic concepts. Thank you.